And now the session has started recording. So welcome. My name is Anastasis. I am a postdoc at the Potsdam Institute, and I was invited to give a workshop on version management and collaborative software development. It will be very interactive. Hopefully we can learn a few things and try them out immediately on our computers. So I hope you are up for it and that you are connected in a way that you can access your email and open a few web pages and do a couple of clicks. And that should be enough to learn a whole lot of things about version management and using GitHub for collaborating with others on writing software or developing models. I will share my screen with a presentation I have prepared. As I said, it's going to be very interactive, so feel free to ask questions at any stage. Just unmute yourself and say, hey, can you repeat that? Or I didn't catch that, or any other question you might have. We have lots of time and we can take it easy, go slow, so that we actually learn something. Wait, I am in the wrong slide. Let's take it from the very beginning. So the workshop has two parts. The first one is about version management in general, and the second is about collaborative software development using GitHub. Let's start with the first part. And before I begin, as I am not sure what your exact interests are for joining this session and what your knowledge on version management and GitHub is, I will take it from the very beginning. I hope this is not too trivial to some and that it is useful to others who don't have any experience in this. So first of all, let's start with version management. So in this workshop, we are going to be talking in general about version management. So we're not going to be focusing on any certain version control tool. This will happen in the second part of the workshop, where we will be focusing on Git. By version, here we mean when you have a piece of software or a model and you're doing improvements or you're doing changes, each new change is a version or can be a version. And this is what we are referring to when we use the word version here. Then management refers to doing our modeling or software development in an efficient and systematic way. In other contexts, you might see the word control, version management. It is basically the same thing. So first of all, definition of version management. A system that does this helps us basically document the history of our project so that ourselves and other people who we work with can keep track of what is happening. So another way to define it is that any earlier version can be recovered at any time in a very easy way. So now that we have the definition, let's see what the objectives are of the first part of the workshop. So we will see why version management is important, what it can do for us. We will see some characteristics, and then just for fun, we will also take a short quiz on version management to practice the things we learned. So let's jump right in. the exercise part, let's see a few examples. Starting off, if we are not using a version management, and let's say we have a model or piece of software or that we are working on, it's stored somewhere on our computer in a folder. It has the name my model 1, and then we make a change, and this becomes our new version of the model, my model 2, and then we think of something new to do, and then we call it the final version, but then another thing pops up and we do more changes, and then it becomes the final. We all know how this works. This can be happening with anything, PowerPoint presentations, Word documents, all sorts of things. And it's tedious, and it's difficult to know what the differences are between all of these versions, first of all. And another problem is that it is difficult to go from one to the other. You have to find where it is stored on your computer, sort them, possibly sort the files by date, and see, okay, what was the status of my project on that date. And another thing is space. All these versions are each a new complete instance of our project. So each one of them takes a lot of space. Let's see what what version management can do to improve this. So if we use a version management tool, we have our previous situation where we had 4 different versions, but this time they are interlinked with each other. This is shown with these arrows. All of them are linked with each other, and the nice feature of version management is that changes between them are not longer duplications of a existing version, and then the newer version only has a slight change, but each new version only contains the differences between the older one and the new one. Let's see how this looks like in reality. For example, here we show how incremental changes work. So we have a file called main.gms. It contains code. It can also contain just text. And we see that the newer version, the version number 2, simply contains a slight difference in 2 lines, which are highlighted here. Newer changes are highlighted with green color, and the rest of the code is white, which means it's not stored on your computer as it is. It's just left unchanged. This way you can see very easily what the difference between a newer and an older version is. And they are connected to each other. We will see how this works. Let's see more characteristics of a version management system. It will contain also some terms. A version management system contains is basically a repository. That's the term that we use for the place where our project is hosted. This is what you see here as an example of the Remind model, which is developed at the Potsdam Institute. It's an energy economy model written in 2 programming languages. And here in this main box, we see the whole repository. So what we see here is the name of the repository. And underneath, we see the contents. We see that we have several folders and several files. Now, this repository, where it is for now of no importance. What matters is that our project is hosted as a repository, and here we can also see a version. We will see how to see versions, how to look at the different versions. And on the right side, another very important characteristic of repositories is that we can see the history. So what has happened in our repository, we can see the changes in time. So you see here you have dates, and you have a word called commit, which is each change that is submitted to the repository and stored as a change is called the commit. This works like this in all version management tools. It's not specific to any certain one. And for each date, you have the commits that happen. So here we see that on January 28, we had one commit. Then on January 26, we had 4 commits by different people. On January 25, we had 2 commits. These are the most basic things of version management and what it can do for you. And the important thing to remember here is that to go from one version to the other, versions are described by commits. We can simply jump from one commit to the other in a very easy way. We saw another example. Now, throughout the development of version management tools, at some point a change happened, and a big improvement was by introducing the notion of centralized and decentralized version management tools. But first, let's see a couple more definitions of important terms that will help us understand what a version management tool does. So, as we said, a repository is the place where our whole project is hosted. So a place that includes both the files and the history. This is seen here. And we saw what versions are. We saw what commits are. We saw what the history is. And now let's see what is a working copy and a remote. So as we said, a repository is a place that hosts both the files that constitute our project and the history. And the working copy is basically our laptop or our computer, and the files that are the files that make our project and where they are stored on our machine. This is just what a working copy is. The word working refers to I might be working on this local copy of my project. I might be making changes there, or trying things out. And it's a place where I can freely play around, let's say. In this sense, as opposed to our working copy, so the place we are playing with our model or project, there is the repository now takes the notion of being the remote, which means our working copy can interact with the remote. So the place where the repository is stored. And from there, it can download changes. It can see what the changes are between our working copy and the remote. So this way, we can very easily keep track of what we are doing. A very common use case is I have done changes in my working copy, and to upload them to the remote, the notion of merge comes into play. So my changes have to be uploaded to the repository so that they are available, so that they are tracked in the history of the repository and that they are available to potentially other people working on this repository. And this happens via merging my changes into the remote, into the repository. This can lead to conflicts in case another person has done changes to the code and it's the same code that I have touched on. Then in this case, my version management tool might not know what to do, which changes have to be the ones that will eventually end up in the repository. So it might ask for additional steps to resolve these conflicts, but we will see what this is in a later stage. For now, let's stick to the things we know now. Another important term is the term branch. We will see what that is. Branching is a very powerful tool that version management tools all contain. And we will see what it does in a later stage. It's a bit more advanced. So now that we have seen a few important terms, we can see the distinction between centralized and decentralized version management tools. So a centralized version management tool is the older approach. So for example, you might have heard of SVN, is that the repository is somewhere online. So in most cases, it was hosted in a server at the institution where I work, or yeah, basically it was hosted by a server. It has this basically rather top-down approach. So the repository is somewhere there, and I usually update my files, my working copy, with all the new changes that have entered the remote repository, and then occasionally I include my own changes by uploading them. In a centralized version management system, you can check out or export the repository. The difference between the two is that when you check out the repository, you download also the history, which means even when you're not connected to the internet, you can jump from one version to the other. Whereas when you export the repository, you just export one instance of the repository in time, and you cannot do much with it. You can only run it or do whatever the project does. But with regarding version management, this is where version management stops. When you export the repository, you just download one instance of it without being able to change anything and keep track of your change, or update something and upload it to the repository. Interaction with the repository, when you have checked out, happens via updating your working copy to include all the new changes and committing your changes to the repository so that they are available for others, and that so that they are appear in the history of the project. So here. One important thing for the centralized version management tools is that you need to be online. You need to be connected to the internet or your organization's intranet to interact with the remote. This changes when we talk about decentralized version management tools. For example, Git is one of those. Here we see that we don't have two separate places anymore. We have a situation where the working copy itself is a repository. So the remote and the working copy can be at the same time, can be basically together. They can be, but they don't have to be. So all the features of a centralized version management tool are available in a decentralized, but it has the additional features of that you can interact with the repository also while being offline. You can commit changes. You can update the project and store it in the history. And in a later stage, when you're back online, you can also interact with the repository that is visible to others. In a decentralized version management tool, the interaction between you and the repository happens with additional terms called pull. When we pull, so we download changes from the repository to our working copy, and push when we upload changes to the repository. And then the word commit still describes the same thing. So one new submission to the repository with changes that are stored in the history. So I hope all this was not much. To see if these things that we talked about are somehow understandable, I have made a small quiz that you can find here. I'm not sure if I can copy it and paste it in the chat. Let me try. I suggest we take some time for you to do the quiz, and then we can come back here. So shall we say we take a 5 minutes break? The quiz is very short. You can take the quiz and then also grab a coffee or drink some water, and then we meet again at 9:30, where we can see the results of the quiz and also take questions from all of you. I will be here in case someone has questions. Feel free to ask, or if the quiz doesn't open, for example, just tell me so we can see if we can do something about it. So here we are again. I hope you can hear me. Not sure if everyone is back in the session. I took a quick look into the results of the quiz, and you did very well. Congratulations! It's very encouraging to see that um, the questions were responded correctly. I had forgotten to mention one thing, which might have created some confusion in the questions, and this is related to the treating of binary files. So a binary file is one that basically does not contain text or code, but some other form of file structure that the operating system understands. And these are not supposed to be treated in a version management tool the same way as text files. This was shown in this slide. No, maybe I had forgotten to mention it somewhere. In any case, it's better to show it here in this example. Here we have a newer version as opposed to the older version, and we see how the changes are only incremental when we use a version management tool, so we don't have to duplicate each time the whole project, the whole code, and only and the differences between the versions are just a couple of lines. In this case, we just store basically the differences, and the duplicated code remains only in one place. And for this to happen, the files that we use a version management tool for have to be text or code, and they cannot be binary. The reason they cannot be binary is that the operating system cannot compare binary files by simply looking at the contents. They are stored as a block, not as lines of code or text. But you did very well also there, which is nice. So going back to our presentation, we basically finished the first part, and now we can start with the collaborative software development part using GitHub. First, let's see what the objectives of this session will be. As I said before, feel free to interrupt me and ask questions of any kind at any stage. If you type them in the chat, I will not see them, so please give me a heads up if you have a question by unmuting yourself. So in this session, we will see why Git and GitHub are suitable tools for collaborative software development. We will hands-on try to start publishing projects on GitHub in case you haven't done it before. And then we will also take a look at typical workflows from examples of teams that work on a project as a group. One important thing that Git and GitHub offers is a very easy and accessible way to make a project open source. As we all know, in the last decades, more and more projects are becoming open source, and it's basically a situation where a model that a project that offers any type of service gains visibility and gains credibility by being open source so that everyone can see what is happening in it instead of the notion of black box that we used to have a lot with models in the past. So let's jump right in. First, a couple of definitions. So in collaborative software development with GitHub, we have to distinguish between what is Git and what is GitHub. So Git is what we described in the first session, is a decentralized version management tool or version control system. It's designed for any type of projects. And documentation and help pages are everywhere online. So you will not be missing any of those. And we don't need to go into very many specific things here. We have to take it from the beginning so that you understand the structure, and that's as far as it goes. The rest you can find it in countless tutorials, and make sure not to get lost in the complexity of Git, because it is indeed a rather complex thing. But the good thing about it is that there is good documentation and that you can survive and do your work very efficiently and nicely also with the basic commands without going into the very advanced parts. Now, as opposed to GitHub is a portal, is a company that provides a place to host software development or project development, version control by using Git. It has additional features on top of Git that are super useful for collaborative software development, which we will see here, as, for example, pull requests, issues, actions. We will see what these things are and how they can help your everyday life. As I see, we are not that many people, and this can be useful so that we can individually address any needs you have and any knowledge that you need in the remaining hour. But for now, let's see how GitHub can be used for collaborative software development. So I am assuming all of you have worked or are working on a project and are interested to know how this could be hosted on GitHub. And by doing so, it will be automatically also managed with Git. So version management will happen automatically once you decide to put your project on GitHub. This doesn't mean that your project has to become public. You can have your project on GitHub and it can still be private only for you, in case you were wondering about that. So on GitHub, people can have their own profiles, and in where they have their own profiles, it's a place only for them, and they decide what is visible and what is not. And then there is also the possibility to create an organization where your whole team or group can interact and collaborate collectively on projects. And again, these projects can be public or private. I say that for now, with a show of hands, you can tell me which of you already has a profile on GitHub. I'm not sure if there is a show of hands here in this. No, there's not really a show of hands.
No, there's not.
There's not. Okay, thanks, Sophia. It's okay. I would say if people are interested, we can take 5 minutes. So good. Thanks, Christina. But if people are interested, I would suggest the following. Those who don't have a GitHub profile, they can go to github.com and create one. And those who do have a GitHub profile, GitHub offers a very powerful security tool, which is called two-factor authentication. And I suggest that those of you who do have a GitHub profile, as an exercise, go to your profile, and in the settings, I will share my screen and show you where this is done. So in my profile, I can go and where was it? Let me find it again. In settings, I can go to password and authentication, and I can basically enable two-factor authentication. It is highly recommended that you do so if you haven't done it already, especially if your team works together in a project and you have a leading role in the project. Because if in a case where your account is hacked, for example, by someone, they can delete the project and then it's gone for everyone. So I highly recommend that those of you who don't have a GitHub profile, who don't have a two-factor authentication in their profile, they do it now. And those who don't have a profile yet, they can just create a profile by going to, let me sign out. Here you are in the github.com main page, and you can sign up by going up here. And then some very, very fancy interface that GitHub has created will start showing you how to do how to join GitHub, basically. Good news is, for now, you don't even have to have Git installed on your computer. We'll see how you can automatically install Git by installing a tool offered by GitHub. So let's take 5 minutes for this, and feel free to ask me questions if you have any. I'm not sure if the chat offers. Yes.
Just let me show you the face as well.
Thanks.
Actually, I have a question, because I'm assuming that. So, what is the best way, if you have any recommendation, to storage these safe codes that when you activate this two-stage, like the two-factor authentication, then it returns a list of codes. And I'm assuming that if you save that in your computer as, recovery codes, and someone actually wants to access that. And I'm asking that because my university was hacked last year and we were stolen data from it. So is there any recommendation to store it, like to I don't know how to say it, to codify that, or I don't know, or maybe to print it and save it in a maybe print it and save it in a piece of paper, right? But if you have any
either that, yeah,
okay.
Exactly. Very, very good question. It's either that or put them in an external drive, not one that can be hacked.
Okay.
Exactly. Not one that is a machine that is connected to anything.
Super.
Yeah.
Thanks.
Yeah. Have you used GitHub already, Christina?
I have an account and I have an organization because we are developing a software, but my team is growing. So the challenge that I have now is that I don't really know. I know Git and I know a little bit of GitHub, but when it comes to more complex projects, it's more difficult for me to manage. Like nothing like the Remind team, for example, but still, it's growing. It's a growing team. So
Cool.
I figure it's a good thing to start with these type of things and organize everything well from the beginning.
Absolutely. Yeah, the branches that I mentioned before, that is a bit advanced, but is a very powerful tool. It's basically the essence of version management, is something that you can work with. And then having an organization on GitHub, and we will see what is the difference between a profile and an organization, offers you the possibility to do lots of project management, basically, with tools such as opening issues and keeping track of teamwork in time and setting deadlines and having so-called boards where you can see progress in reaching a goal in your team.
Okay.
If we have time in the end, we can definitely also look at things like this, and we can even do them hands-on. You can share your screen, and we can do a few clicks and activate the project part of your organization, or activate the issues part. Yeah.
Nice. And let me ask you this: what do you work with? Because so some of the code I have is in R, and with R Studio, it's fine. Like I know how to settle that and work directly on R Studio. But when it comes to Python, I'm not really do the same. Is that something that you were planning to talk about? How to use local apps to uh,
Yeah,
to
I don't
work with
remember if
GitHub?
I don't remember if I have it in the presentation. I can simply say, indeed, RStudio offers a very nice interface. It contains a Git module, basically, so you can interact with your team and your repository directly from RStudio. But this is just one of the several ways that you can do it, depending on what platform users have. So Windows, Linux, Mac. Um, the tools indeed differ, but for most of the people where the main tool is the main platform is Windows, people can use GitHub Desktop.
Okay.
Have you heard about it?
Yes, yes, I
It's a
know.
it's just a program that you install on your computer, and the nice feature is that it also installs Git on your computer, so you don't have to install it
Okay.
by hand. Yeah,
Okay.
this is one recommendation I would have. I myself work a lot with RStudio because we do mostly R. So to know what to do for Python, for example, you might have to ask a Python expert. I'm not an expert in Python.
Okay. Thank you.
You're welcome. So now the 5 minutes have passed. I hope everyone had the chance to either create a profile or to see if activating two-factor authentication is something that would be useful for them. We can move on. Let's go back to the presentation. So we will see how an organization can be set up for a whole team if there is time in the end, and if there is interest in doing such thing. And then assigning roles is also a part of creating an organization, so we can skip that for now. But once you have created a profile, you can import your project into your profile. Let's see, here it says organization, but you can also do it in your profile. I will, again, for now, stop sharing, and let's take a look how this can happen. So I am here in GitHub. I actually already have an account. I made a test account. Okay, let me find my password again. It basically is something that potentially many of you would have done just now. So I signed in my account, and basically there's not much to see here. My account is brand new. If I go to my profile, there's only one repository, which I created an hour ago. And my goal here, wait, am I sharing? I'm not sharing, right?
No, no, you're not.
Sorry. So you didn't see any of this. Oops.
No, we didn't.
So here is my brand new account. It's called Mixa Berlin. And it's when I go to my page, github.com Mixa Berlin, I see up here a menu which has the most important thing is my repositories. And if I go to my repositories, there's basically only one. But let's say in your case, as you see, mine was updated an hour ago and doesn't contain much. Let's see what the workflow is to basically start hosting a project that you have in your computer and it has not used version management yet. And start using version management by uploading it to GitHub. And as I said, it can still be private. It's not doesn't mean that you will share this code with anyone. It will still be your own private thing. Only you will have access to it. But by using GitHub, you will have a good, very good starting point to start keeping track in a clean way of your code. So you can go to the green new repository button, give it a name, new repository. I guess you can choose any name. It can be private, as you see here, you can choose. And you can basically just create it. And there it is. It is seen up here. It belongs to the user Mixer Berlin, and it's called the new repo. That's what how projects, Git repositories are stored. So you have a name of a person or organization slash the name of the repository. So now that we did this, so if you haven't used GitHub at any time before, you can, and you want to upload your cool project or model or whatever, you can just go here and upload an existing file. Let's see. So I have some files here. Let's say here I have some files from an R project. I can basically pick all of them and upload them to the repository. If you remember, we talked about commits. So each change you do in your repository is a commit. So I can say that adding files was the very first commit, and I can immediately commit these changes. And now my repository seen here contains files. The files are seen here. And I can also click here in this clock to see the history of my repository. There's not much happening. We see one commit, which was the one we just did by adding files. Now, the nice thing about Git is that I can very quickly, even from inside Git, I can go to a file. This can also happen on my computer. I'm just doing it here so you so we can see it quickly because we only have half an hour left. I can edit the file. Let's see. I did one small change. It's run analysis tool. It's cool run analysis tools because they are super cool. And the Git nicely also adds a recommendation for the commit name, but I will add my own. Update. And I can commit the changes. Let's skip the branches part for now. So what happened now is that I created a new commit. Let's go back to the repository page. And now you see the little clock shows that there were 2 commits in the repository. And if we go to the history, we see each commit is one item in the history. And now the notion of incremental changes, as you will see, is shown here, where we see with red, we see that the only thing that this commit did, the update description file commit, is changing one line of code. The rest of the code is unchanged and it's not stored 2 times. It's still the same, so there's no need to store it 2 times. We only see that we can go from one version to the other by just seeing one slight change. I hope all this is not too confusing. I will show now how we can use GitHub Desktop to do the same thing on our local machine. So I would start the program GitHub Desktop, which you can download at any stage. And I think it's platform independent, if I'm not mistaken. I'm sure it exists for Mac, definitely exists for Windows. I'm on Windows now. And it should exist also for Linux, but those who use Linux, if you use Linux, it means you already know what Git is, and Git is already pre-installed as a program on Linux. So I guess there's no need to go into this now. Let's see. I can, in GitHub Desktop, clone a repository, which basically means I can download the repository from GitHub on my computer and do all this work also locally on my computer. And as I said before, you can even do it offline. And then I choose the URL of my depository. Remember, we said it's the name of the person or organization, and then the name of the repository. I choose a place to store it on my computer. Let's just put it in a new folder on my computer. And now GitHub is cloning. Oops. How did we call it? We call it Mixer Berlin new repo. Private. So yeah. So here's the thing. Okay. Now I am using my official here in GitHub Desktop. I am logged in as in my official work account and not in the Mixa Berlin account that I created for the purpose of this. Excuse me. For this workshop. And the repository, as you see here, it's private. So it means only I can clone it. An easy way to overcome this is I will set it to public so that we can clone it. But in your case, you can still stick to private. And when you are in GitHub Desktop, you will be logged in as your with the same account that you created the repository. So I'm changing. I'm changing the visibility. It says it's in a danger zone for good reasons. So you want to make it public. And now in GitHub Desktop, I can clone it. So here we have the repository in GitHub Desktop, which means I can see the history. Remember these things that we saw online here. Remember the history that we saw here online. Now, this is what you see here is just my computer. No internet needed. I can see the history on my computer. I can do things. I even can create new commits by making changes in the code. We will see that in a minute. And everything is documented, and version management is working also without the use of the internet. Let's see how this can happen. So for example, one good tool, as we said before, is RStudio because it contains a Git module, but you can also just open a file. I can go to the files. Oops. Let's go to the files and see what happens when I make a slight change. Wait, I have it in documents, GitHub, version management 2, new repo. So I can edit a file. Let's just edit it with Notepad, very basic things. And let's change something. These are very cool run analysis tools. Let's save it and see what happens. So once I change the file, see that immediately GitHub Desktop realize there's a change and it shows it to let me know that a file is different than the image that I have of the repository that I had downloaded, I had cloned from GitHub. And the cool thing is that even while not being online, I'm working in a remote place or I'm working in a train, I can commit these changes. So new addition to description file. It's good to give very meaningful names to your changes so that when you see them in the history at a later stage, so when you see them here, you know what they are about. Don't say just commit 1, 2, 3. Say in this commit, I can even go and say added the word very to the description file. Trust me, this will save you lots of frustration in the future. And now I can just commit it. And what happens here is that now my repository doesn't have any new changes, so it's clean. It has this history, as we said. This was the initial commit where we just added the files. This is the first change that we did online. And you see here, This is just one change, and then another change that we did just now, that we did here locally, and it's shown in the same way. And now we see a small change in what GitHub Desktop is showing us. It shows us that there's one local change that is not yet in C. Here, I'm loading it again. The history of our remote, so what is on GitHub, is different than the history of what we have here. Here we have one item more. What I can do is I can push my changes to the remote repository, and I will show you how this is done. It's very easy. Yeah, okay. I'm still signed in as you can see it here. See here the commit by Mixa Berlin, which is the account I created for the workshop. This is also by Mixa Berlin, and this one is me. I'm signed in GitHub Desktop as Anastasis. If I was signed in as Mixa Berlin, then I would just push the origin, and my changes would automatically appear also online on GitHub. But the fact that I cannot do it now actually gives us a very nice way to jump into another topic, which is when you work on a project with others and you have different users and you have one project for all the users. What you can do is going from an organization, and we can go and create an organization. Actually, I think I did create one. Let me see. Where was my organization? Here is my organization. I created it for the workshop. So I called it ECMP, the name of the conference. It's very easy. Anyone can create an organization. I just did it for you so we don't have to do it. And the organization is empty. It has no repositories. We can create a new repository. And what we can basically do is we can import a repository from somewhere else. And let's take the repository as it is and import it in the organization. It will be public. The cool thing about importing a repository into an organization is that you also import the whole history. You will see it now in a minute. We can go, and here we see now that in our organization ECMP, we have a repository called new repo, which is exactly the same as the one I had as a user. And it has exactly the same history. Now, the cool thing about it is that if I add users to this organization, I can go to the settings. I can add people. Let's say I add my other account. This is me. I can give myself. Oops, what happened? Did I accidentally refresh or something? Let's see. I'm not sure if. Here are the members. Let me try that again. So here. Now I have invited a person, basically me. I can also invite you people. The important thing is that now these collaborators, they can interact with this project by doing something very basic to GitHub, which is they can fork this repository. Forking a repository means they can upload it to their own profile, work there as if it was a completely separate repository, but they can also interact with the main repository, which is the one hosted by the organization. And this way, there is an additional safety valve for changes that happen in the code that can lead to unwanted results by a feature called pull request. And I will go back to the presentation to show you how this is done. Schematically. So as we said, we had created an organization, ECMP. It will be whatever name you want to give it in your own case. And this organization has members. You saw how I added a member. So the best way to interact with the project is if members can fork the project to their personal profile. And this is seen schematically down here. So the vertical line is separating the organization, which is the left side, with your own profile, which is the right side. And if you fork, which is the button that we saw here, if a person forks the project, the repository to their own profile, it will be existing in their own profile. And then with what we saw even before that, what we did in GitHub Desktop, they can clone it. And this separation by the horizontal line is showing the online versions of our repository, and the lower part is showing the local versions of our repository. You can see it from here. You have URLs, and here you have local paths on your computer. So the workflow is as follows. A person can fork in their GitHub profile the project, and then they can clone it to do changes in their local computer, as we did before. We saw this here. We did this change locally. And then they can upload the changes from their working copy to their GitHub profile. And in a last stage, they can open a so-called pull request to merge these changes that they did locally into the main the main repository that is shared with the rest of the team. Now, what is pull request and why it is useful? It can be seen here. Let me see if I can do this very quickly. I'm creating a new fork in my personal profile of the repository. Now, as you see, I am in my personal profile. I see it here. I'm not in the CMP. I'm not in the organization. And this is the repository. Let's say I did a small change. Let's go and edit a file. This, as I said before, it can also happen locally. I'm just doing it here. So that we see it quickly. When you do changes, you can also preview your changes. So this is how the commit will look like once you have completed it. I commit my changes. So my local repository now has changes. And as you will see, GitHub is now notifying me and saying that my branch is, so by branch here, we mean my local, my personal copy of the repository that is forked, you can see that it's forked here. It's very useful that Git gives you lots of information to have an overview of what's happening. So it tells me that I have forked this repository from the organization, and now it tells me that it's one commit ahead. This is useful because it tells me, oh wow, maybe I can contribute my changes to everyone so that they also have them available and can use them if they want. And to do this, you can open a pull request. This is a very nice feature of GitHub. And why is this useful? The reason it's useful is because you can assign reviewers. So reviewers are other persons in your team that you can ask to check your code and see if they agree with your changes. And only after they have said that they agree with the changes, they will be able to be included. So I created the pull request. It's in here. I can add a reviewer, but unfortunately, we have no one else in the team. But here would be the reviewer that would be responsible to take a look at the code, and once they have seen it, they would either allow for it to be merged or say that they want changes. But the nice thing about GitHub is that when you open the main page of a repository, in the menu up here, you can go and see a list of pull requests that are currently happening. So this is the one I just opened now. It's about to be merged if someone set it free. Let me show you how this is done in a project that is already up and running. This is the Remind model. It's a rather big thing. It has 3,900 commits, has been developed for several years now. It has, how many people working on it? Several, like 50. Here, 40 contributors. And this is the name of the organization. This is the name of the repository. And here you can see a list of the pending pull requests. So this list is people who have opened a request to add code to the repository, and someone is assigned as a reviewer. Here you see people who are assigned as reviewers to check their code, and only after the reviewers have given their feedback, this code can be merged into the repository. Okay, now we only have 10 minutes left. I wanted to talk to you about project management by using organizations on GitHub. I can do it very quickly by showing you things that happen here. For example, a very powerful tool of GitHub is opening issues. So we have a repository, it's called Remind, or the other one we just made, it's called New Repo. I can go to the issues section. I can start a new issue where I choose from the different categories of what the issue can be. It can be a bug. It can be all these lists, all these things that are listed here. It can just be a question. Why is this like that? And I can link parts of my code into this issue, and they will be nicely shown here. So project development can be happening collaboratively, transparently, and in a very tidy fashion, so that in the future you can see what happened when, by whom, and in what way this happened. And once this has happened, you can also go to the projects section and create a new project. And by creating a project, you will have access to a situation like the one I will show you here. There's no time to make such things, but You can see how it looks like. You have the so-called board. This is how it looks for Remind. We have a project called Development Issues. And in here, we have a board. The board is separated in lists. So we have issues to do. All these little boxes are issues like the one I just created in our repository. Then we have sections in our board, like stuff that is about to happen, stuff that is happening now, stuff that is done. This lets us very nicely have an overview of what is happening in our project. And these little boxes, you can be dragged and dropped from one section to the other to very quickly update work that is happening on your project. Last thing about Git, and maybe after we can finish, is branches. I will not go into branches now because they might create confusion. I encourage you to read Git and GitHub documentation. It is available everywhere. Just type Git tutorial or GitHub tutorial, and you will find lots of things, and you will see many of the things I have just mentioned. You will see them there, and maybe they will ring a bell. But I hope that this was helpful in some way, and I might have time. Yes, I do have 5 minutes. In case you have questions, feel free to ask them. Okay, doesn't seem to be the case.
We have one in the chat.
Oh, I don't see it, but maybe I have to scroll down. Hi, Gurkem. I can say a few things about YAML files. Yes. So first of all, YAML files can be included as just simple code files in a project, and Git will be keeping track of changes that happen in them, and the same way I did changes in text files, there can be changes in YAML files, and they will be documented by Git. But maybe, and I guess this is what you are referring to, you're referring to YAML files that are used for GitHub Actions. GitHub Actions is a very advanced thing. In such a short workshop, there would not be time to go into this. But I can tell you that, for example, if you go to the Remind model, you will see that there is a YAML file here, for example. No, I'm not sharing. Or am I? Boom. I've forgotten if I'm sharing or not. Let me see. No, I'm not sharing. So sharing my screen again. Here's the Remind model, a big organization hosting a repository containing lots of files, as you hear. And here's a YAML file. So what does this YAML file do? It contains a predefined structure. If you ask about YAML files, you probably know what they are. It's a way to write code or anything so that it's readable both by humans and machines. So what we see here is a YAML file contained in the Remind model, which basically contains a recipe. It contains instructions for a action that you want to be performed by Git automatically before any commit happens. It's called pre-commit configuration YAML file. So this is one usage that a YAML file can find in GitHub. I hope this somehow answers your question. Oh, wow. This is very fancy. What's happening now? So I stopped sharing again because sharing got crazy. Ah, okay. Görkem is not here anymore, so I'm not sure if he had the chance to listen to my response. Thank you, Andres. And thank you, everyone. I think we can close the session now. Thanks, Sophia. If you have questions, you can find me in the platform
Thank you.
and ask me at any stage. Bye-bye.